In today's economy, cash flow is tight, and families are held captive to high interest rate credit card debt. Churchill Mortgage can restructure your current mortgage and significantly reduce these problems. Get a free analysis and learn how to eliminate credit card interest rates, lower bills, and start taking control of your budget. Get started at churchillmortgage.com. This is a paid advertisement. NMLS ID 1591. NMLSconsumeraccess.org. Equal housing lender. 1749 Mallory Lane, Suite 100, Brentwood, Tennessee 37027.
This is SpaceTime, Series 26, Episode 25, for broadcast on the 27th of February 2023. Coming up on SpaceTime, the discovery of massive early galaxies defies science's understanding of the universe. Seismologists discover an innermost inner core at the center of the Earth, and that crew of the leaky Soyuz spacecraft will be stuck on the International Space Station until at least September. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, it looks like astronomers will have to rewrite their textbooks after NASA's James Webb Space Telescope discovered the seemingly impossible. 6 massive galaxies, each almost as big as the Milky Way, but at the beginning of time. Each of these galaxies contain around 100 billion times the mass of the Sun, but were detected at a time when the universe itself was only 500 to 700 million years old. The findings, reported in the journal Nature, raise some serious questions about how such big galaxies could have formed so quickly in the early universe. One of the study's authors, Joel Lear from Penn State University, says these objects are simply far more massive than anyone could ever have expected. He says astronomers only ever expected to find tiny young baby galaxies at this point in time. But instead, they've discovered galaxies every bit as mature as the Milky Way in what was previously understood to be the dawn of the universe, a time when the cosmos was just 3% of its current age. Launched in December 2021, Webb is the most powerful telescope of its kind ever built. And it's equipped with infrared sensors capable of detecting light that was emitted by the most ancient stars and galaxies. Essentially, this telescope allows scientists to see back to a time roughly 13.5 billion years ago. That's when the first light in the universe began to shine, ending the cosmic dark ages and bringing forth the epoch of reionization, when the universe began to look the way it does today. The images are part of Webb's Cosmic Evolution's earlier release science survey. Basically, it's a deep look at a fairly boring patch of the sky close to the Big Dipper, a region of the universe which the Hubble Space Telescope first observed back in the 1990s. Leah says because this is science's first glimpse so far back, it's important to keep an open mind about what we're actually seeing. He says while the data indicates that these are likely galaxies, there's still a very real possibility that some of these objects at least could simply be supermassive black holes. But regardless of what they are, the simple fact remains the amount of mass discovered means that the known mass in the form of stars at this period in the universe's existence is up to 100 times greater than what scientists had previously thought. In fact, even if they were to cut the sample in half, it would still be an outstanding discovery. The revelation that massive galaxy formation began so early in the history of the universe upends what many thought was already settled science. Leah says his team have been informally referring to these objects as universe breakers, and they've been living up to that name so far. He says the galaxies the team have discovered are so massive they're in tension with 99% of all models of cosmology. Accounting for such a high amount of mass would require either altering our models of cosmology or revising science's understanding of galaxy formation in the early universe, namely that galaxies start out small clouds of stars, dust and gas and gradually grow larger over time through accretion. But the fact is either scenario would require a fundamental shift in our understanding of how the universe came into being. Leah says the team looked into the very early universe for the first time and had no idea what they were going to find. But it turns out what they found was so unexpected, it's actually creating problems for science. It calls the whole picture of early galaxy formation into question. The next test will be to confirm the team's finding and alleviate any remaining concerns by taking spectrum images of the massive galaxies. That would provide data on their true distance and also the gases and other elements that make up these galaxies. The team could then use that data to model a clearer picture of what the galaxies looked like and how massive they truly were. A spectrum will immediately confirm whether or not these things are real. It'll show not just how big they are, but also how far away they are. Now, it's worth pointing out that these latest finds aren't the earliest galaxies observed by Webb. As we've reported previously, last year another team of scientists spotted 4 galaxies that likely coalesced from gas even earlier, around 350 million years after the Big Bang. That was a time when the first stars were thought to have formed. Those objects, however, were tiny compared to these new galaxies, containing many times less stellar mass. It all goes to show that the universe isn't just stranger than we imagine, it really is stranger than we can imagine. This is SpaceTime. Still to come, discovery of an innermost inner core at the center of the Earth. And it looks like the crew of that leaky Soyuz spacecraft docked to the International Space Station are going to be stuck there until September. All that and more still to come on SpaceTime. Seismologists have detected what they're describing as a distinct and separate innermost inner core at the center of the Earth. The discovery, reported in the journal Nature Communications, is based on seismic wave data that's travelled through the deepest parts of the Earth's inner core from earthquakes on the opposite side of the planet. By measuring the different speeds at which these waves penetrate and pass through the Earth's inner core, the researchers believe they've documented evidence of a distinct layer inside Earth known as the innermost inner core, a solid metallic iron-nickel ball that sits within the centre of the inner core. Of course, not all that long ago, it was thought that the Earth's structure was composed of 4 distinct layers: a thin crust, a very thick mantle, a molten liquid metallic outer core, and a solid metallic inner core. These new findings confirm there is a 5th layer. The existence of an internal metallic ball within the inner core, the so-called innermost inner core, was first hypothesized about 20 years ago. And the new seismic data provides another line of evidence supporting this hypothesis. One of the study's authors, Professor Hervé Kalsic from the Australian National University, says studying the deep interior of Earth's inner core can tell science more about the planet's past and evolution. He says the inner core is like a time capsule of Earth's evolutionary history, a fossilized record that serves as a gateway into the events of our planet's past, events that happened on Earth hundreds of millions to billions of years ago. The authors analysed seismic waves that travelled directly through the Earth's centre and were spat out on the opposite side of the globe from where the earthquake was triggered, known as the antipode. The waves then travel back to the source of the quake. Kalsic describes the process as being similar to a ping-pong ball bouncing back and forth. By developing a technique to boost the signals recorded by densely populated seismograph networks, the authors observed for the first time seismic waves that bounce back and forth up to 5 times along the Earth's diameter. Previous studies had documented only a single antipodal bounce. The new findings are providing a new way to probe the Earth's innermost core and its centermost region. One of the earthquakes the scientists studied originated in Alaska. The seismic waves triggered by this quake bounced off somewhere in the South Atlantic before travelling back to Alaska. The authors studied the anisotropy of the iron-nickel alloy that comprises the inside of the Earth's inner core. Anisotropy is used to describe how seismic waves speed up or slow down through the material of the Earth's inner core, depending on the direction in which they're travelling. It could be caused by a different arrangement of iron atoms at high temperature and pressures, or preferred alignments of growing crystals. The researchers analysed data from some 200 magnitude 6 and above earthquakes over the last decade, and they found the bouncing seismic waves repeatedly probe spots near the Earth's centre at different angles. By analysing the variation of travel times for seismic waves of different earthquakes, the authors infer the crystalline structure of the innermost inner core is likely different from the outer layer of the inner core. They say this might explain why the waves speed up or slow down depending on their angle of entry as they penetrate the innermost inner core. The findings suggest that there could have been a major global event at some point early during the Earth's evolution. And this event was cataclysmic enough to cause a significant change in the crystalline structure or texture of the Earth's inner core. Galzic says there are still lots of unanswered questions about the Earth's innermost inner core, and these could hold secrets to help piece together the mystery of the planet's formation 4.6 billion years ago.
Firstly, we observed these unprecedented waves that ricochet through the Earth several times. So they reverberate along the Earth's diameter, and you can think of a ping pong ball that's going back and forth along the same direction. And this is how these waves behave, and they were captured for the first time up to 5 reverberations. Before that, we had only up to 2 reverberations. And at the time the study was published in 2002, there were all direct waves through the center of the planet, only 1 reverberation. So when you think about the difficulty of this problem, it is because we don't have a volumetric sampling of the innermost part of the inner core in all directions. For instance, you have a large earthquake somewhere on the globe, and most likely the antipodal point, so on the opposite side of the globe, will be somewhere in the ocean. So you can see why we have to be innovative in a way we capture new information and add new data so we can improve that volumetric coverage of the inner core. So then we are in the same position as medical doctors who study the internal body of a patient by having sources and receivers everywhere around the body.
It showed an additional layer, a layer which up until now hasn't actually been evaluated.
So we basically confirmed the existence of the innermost inner core, and we're able to put some bounds on its radius. So imagine the inner core is a solid ball of iron and nickel with about 1,220 kilometer radius. The innermost inner core's radius is about 650 kilometers with some uncertainty, but it is approximately halfway down between the inner core, outer core boundary and the center of the Earth. And secondly, we were able to characterize that transition as gradual rather than sharp. And this may explain why it is so difficult to detect, because for most of the other Earth layers, you have a fairly sharp boundaries between them because they are typically different chemical compositions or phase changes. So we can observe the waves that reflect directly off those boundaries. Whereas here, we don't have such a sharp boundary, and that means we have to study the waves that move directly through the innermost part of the inner core. And when we did that, we found that the waves that move through the innermost inner core show a different property than those that move only in the outer shell of the inner core. And the difference is in the speed of travel. Namely, the waves that move through the innermost inner core slow down in the direction that is somewhere between the spin axis of the Earth and the equatorial plane. Whereas the waves that travel through the outer shell only have the slowest parts or the slowest directions in the equatorial plane. So there is this subtle difference in the way that these two different parts of the inner core slow down seismic waves. And this is what we were able to measure and differentiate between the two.
What does that tell you about what's going on down there? Is it just a case of the nickel and iron just getting more and more compacted, reaching a higher and higher pressure and temperature?
It could be. Yes, it could be. This is one hypothesis that perhaps there is a phase change. So perhaps they're talking about 2 different crystallographic structures of iron. There's an ongoing debate on whether iron is in a hexagonal closed packed form or in a body-centered cubic form. And that would make the difference. So we need another line of evidence or multidisciplinary approach to understand that because, of course, everything we do in global seismology is geophysical inference. We try to characterize as much as we can transitions or different structures, but we do need experiments at the high pressures and temperatures to complement our research. So I mentioned that as one hypothesis. Another one could be that perhaps you don't have a phase change in the crystallographic structure of iron, but you have a mechanism that drives a different growth of the inner core in the sense that the crystals of iron grow in a different direction or with a different rate. And so you can imagine that perhaps if you have an aggregate of crystals, you can have a preferred or aligned orientation of these crystals that will then either slow down or speed up seismic waves in a certain direction.
What about the idea that the composition itself is different, that there are more oxygen in the inner core than we thought there was? Maybe there are other elements down there which are affecting the overall structure.
There is a possibility, of course, and
This is all
everything.
speculation,
Because everything that we can infer from seismic waves should be taken. All interpretations should be taken with a grain of salt, and the inability to see what's down there. The best we can do is to study the seismic waves and, so to speak, travel to that part of the planet on the crest of seismic waves. But you mentioned the chemical composition. We know that the inner core is an alloy of iron and nickel with some light chemical elements, and oxygen is one of the most serious candidates apart from few other light elements. So it is possible that perhaps you have certain packets of these light chemical elements that could change the speed of seismic waves. And in that sense, there's a trade-off between the absolute velocity of seismic waves that move through the inner core and the anisotropy, the property of material to behave differently in different directions. Because we talked about this transition between the innermost inner core and the outer shell and possible differences and what they might mean. I would just like to say that, studying and understanding how the inner core grows, how quickly it crystallizes out of the liquid outer core, and how that process looks is almost like a frozen record of the Earth's history. And this is why we study it, because the inner core, in a sense, is like a time capsule that can record the history in the same way that, for instance, nodes on trees can record their climate conditions.
Yeah, but you can grab a tree and cut it open and have a look at that. With the inside of the Earth, it's much harder to get there.
It's much harder to get there, and this is exactly why we have to be innovative in the ways we treat the existing data and find the new data to sample, in this case, the center of the planet.
So where to now? Is it just a case of getting more and more seismic data to verify the transition area?
That is certainly one direction. Some new directions of studies in the last several years and perhaps the last decade is to look not just at direct waves, but actually the similarity between seismic waves and those late arrivals, many hours after the large earthquakes happen, actually. And this is how we recently scanned the core of Mars, where, interestingly, we have a single seismometer, whereas on Earth we have tens of thousands of seismometers, and still the image that we are getting of the Earth's deep interior is still blurry, but it's getting sharper.
That's Professor Hervé Kalsic from the Australian National University. And this is SpaceTime. Still to come. Moscow says the crew of that leaky Soyuz spacecraft docked to the International Space Station will now have to wait until around September before they can return to Earth. And later in the science report, a third patient now in remission from AIDS. All that and more still to come on SpaceTime. The Russian Federal Space Agency Roscosmos says the crew stuck on the International Space Station after their spacecraft sprung a leak won't be returning to Earth until September, a full year after they first launched. The crew of 2 Russian cosmonauts and an American astronaut flew to the orbiting outpost aboard their Soyuz MS-22 spacecraft from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan in September 2022 for what was meant to be a 6-month tour of duty. They were slated to return home aboard the same capsule on March the 28th. However, that capsule suddenly began leaking coolant in mid-December after apparently being hit by a micrometeoroidal piece of space junk. Mission managers eventually decided it was simply too dangerous to send the crew home in the damaged Soyuz and instead opted to send up the next Soyuz in line, the Soyuz MS-23, in an unmanned configuration as a rescue ship for the stranded crew. However, on February the 11th, just after a new Russian Progress MS-22 cargo ship successfully docked with the Zvezda module of the space station, another Progress cargo ship, the MS-21, which was docked nearby, also suddenly sprung a leak in its coolant system. Now, the Progress is very similar in design, construction and equipment to the Soyuz. And the fact that now two Russian spacecraft docked to the space station had both begun leaking coolant raised some serious concerns. It forced Moscow to delay the launch of the rescue Soyuz until they could determine what was really happening. Roscosmos now claims the Progress coolant leak, just like that of the Soyuz earlier, was also caused by a micrometeoroid or space chunk impact and not some sort of manufacturing quality control issue. The agency says it's based its conclusions high-resolution images and videos of the Progress MS-21 taken by the space station's 17-metre-long Canadarm2 robotic arm, which revealed a 12mm hole through which coolant fluid was pouring out from the cooling system and also some damaged solar panels. Now, because Russia can only build spacecraft at a certain rate, the MS-23, which has just launched for the space station and which was to take up a new crew, has instead flown up empty, meaning that new crew has been bumped back by 6 months. And to fill the gap, the existing Soyuz MS-22 crew will stay up for the extra time. Now, while all that was going on, Moscow also took the opportunity to announce that despite earlier statements, Roscosmos will extend its participation with the International Space Station program until at least 2028. That reverses last year's threat to leave the space station after 2024, and I'm quoting here because it's old and broken down, and instead concentrate on Russia building its own space station. Moscow has been working on a new space station core module at Energia, but that's well over budget and years behind schedule. In recent years, Russia's space program has suffered a string of failures and leaks. These have led to the loss of several satellites, as well as manned spacecraft, and numerous games of hide and seek aboard the Russian portion of the International Space Station as crew try to find where the leaks are coming from. The International Space Station has remained a rare venue of cooperation between Moscow and Washington ever since the start of the Russian invasion of Ukraine a year ago and the ensuing Western sanctions against Russia in response. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A patient who was treated for leukemia with stem cell transplantation has now shown 9 years of persistent suppression of the human immunodeficiency virus HIV. The findings, reported in the journal Nature Medicine, suggest that this latest patient could follow the famous London patient and the Berlin patient, who both underwent similar treatments and are now considered cured from AIDS. The latest patient is a 53-year-old male with HIV who was diagnosed with acute myeloid leukemia in January 2011. During his stem cell transplant for the cancer, he received bone marrow from a donor with a mutation in the gene for the HIV-1 receptor CCR5, which makes the cells resistant to HIV infection. The HIV eventually became undetectable in the patient's blood cells, so antiretroviral therapy was stopped in November 2018 to see if the infection would return. But the patients remained in remission ever since. While stem cell therapy is a high-risk procedure, the medical team says the case study adds to the previous 2 cases and could one day allow HIV treatment and remission. HIV, the human immunodeficiency virus, causes the acquired immunodeficiency syndrome AIDS, which is transmitted through body fluids. First diagnosed in June 1981, the World Health Organization estimates that up to 113 million people have been infected with HIV and over 49 million people have died of AIDS. A new study warns that 2 of humanity's biggest animal food sources are also 2 of the planet's worst polluters. A report in the journal Current Biology found that the food fed to both farmed chickens and farmed salmon accounts for 78 and 69% respectively of their environmental impact. The findings are based on detailed scientific maps charting greenhouse emissions, nutrient pollution, fresh water use, and spatial disturbances of the chicken and salmon farming industries. Humans may not hibernate, but scientists have found that your sleep does change with the seasons. The findings, reported in the journal Frontiers of Neuroscience, are based on data from 188 patients who had undergone sleep studies. It found that RME, or rapid eye movement sleep, that's the deepest sleep that people have, tended to be 30 minutes longer in winter compared to summer. While this kind of study can't show cause and effect, RME sleep is directly linked to your body clock and circadian rhythms, and that can be affected by changing light conditions. Researchers say this trend, however, may not be seen in future studies in healthy people, and so more research will be needed. Further, most of the diagnoses of these patients showed no seasonal patterns, but insomnia was more commonly diagnosed towards the winter months. A new study has found that most fake news on social media platforms is being spread by algorithms that reward the biggest gossips by amplifying their chatter more than less frequent users. Tim Mendham from Australian Skeptics says it seems the biggest gossips are responsible for 6 times as much fake news as non-gossips.
This study looked at about 2,500 Facebook users and people who were sort of quite active Facebook users, trying to find out why individuals were spreading misinformation, especially about the pandemic, etc., which is the big issue. What they found out was that the social media platforms, or in this case Facebook, was actually incentivizing people to share information and to pass it on. And the more you were a sharer of information, the higher up you got on the list of things worth looking at in Facebook's algorithms. So basically, it was almost like a technical effect that if you were spreading information, good or bad, it really didn't matter much. And if you were doing it a lot, your messages were being seen by a lot more people because it was going up higher in the list. So what they found out was that there was a small percentage of particular users, I think they were talking about 15 to 20%, who were accounting for a very large, I think double that number, for fake news. So, 10, 15% accountable for 30 to 40% of fake news items, which means they're the active spreaders. So what they suggest is that it's not necessarily because they are conspiracy theorists, although there are obviously a lot of this fake news is about conspiracy theorists. They're not necessarily anti. They suggest that it's just because they share a lot. They're almost obsessive sharers. And because they're obsessive sharers, Facebook rewards them for spreading the message, for using Facebook a lot. And I'm sure the same thing happens to most of the social media platforms as well. Probably happens with Twitter, probably happens with a lot of different things. But what they're suggesting is that these people are not necessarily spreading because they're stupid or because they have a particular conspiracy. They just like spreading, and the platforms reward them for spreading, so they do more spreading, which makes them even higher.
They're just gossipers, and they like to gossip.
In a way, and they're suggesting if they could actually convince them to spread factual information, it'd be very handy. And this study suggests that there's probably not a lot of difference from the point of view of the spreader, whether it's true or not. They just like spreading. So if you nudge them into the right direction of not spreading misinformation, but spreading proper information, it might actually end up being a good thing, that you're therefore encouraging, incentivizing people to spread good news, proper news, true news, rather than fake stuff. But at the moment, these people are just spreading willy-nilly and spreading anything, bad or good or whatever. But it does mean that because they're spreading so much, this small cohort of people is accounting for a lot of the misinformation that's going out there.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.